manually defining a model's PMI can take quite a bit of time. As you can see, just adding datums, dimensions, and tolerance definitions to this simple part can take me several minutes to complete. So you can imagine how long it might take to manually define a more complex part. Also, the more complex the model, the more likely I am to make errors when defining its PMI. The SOLIDWORKS DimXpert can automatically create model PMI for you, based on common industry standards such as ASME or ISO. When you want to quickly attach PMI to a model, or lack familiarity with specific dimension and tolerancing requirements, using this tool can be quite helpful. You can activate the tool from the DimXpert Manager, or from the MBD Command Manager. I'll go ahead and delete the PMI I've manually attached to this model, and then activate the command. The first settings I need to define are for the part type, in this case, prismatic. The type of tolerance applied, I'll go with geometric for this example, and the dimensioning layout for patterns. I'll use linear in this case because I'm not dealing with any circular patterns. The next section is where you'll define the model datums. These are the references that each feature will be dimensioned from and are what defines the 6 degrees of freedom possible for a three-dimensional part. I'll choose the top face for the first datum and click the right mouse button to quickly jump to the second datum selection. I'll choose the front face for that selection, right-click again, and select this right face for the tertiary datum. The scope is the last section I need to define. I can toggle all features to have SOLIDWORKS look for and define all the features in the feature filters list, and I can also refine the definition by checking or unchecking certain features in the list. Toggling selected features lets me select specific features in the graphics area to define, like this hole pattern. I want to define all features in this example, so I'll select the option and click OK to attach the PMI. As you can see, all the annotations required to fully define the model have been attached and use a consistent scheme. In addition, note how all the model features display in green. This is because the Show Tolerance Status tool was automatically activated to let me know which features in the model still need to be defined. In this case, everything has been defined. But if I delete the notch feature from the tree and activate the tool, you can see the notch is now the color of the model, indicating that information still needs to be added to fully define it. And if I expand the hole pattern feature and say, suppress the position portion of the annotation, the geometry displays in yellow to let me know the feature is partially defined. If any geometry is overdefined, it displays in red.